Hi everyone, welcome back to Basic for Beginners. Today we are going to talk about regression. Previously, we discussed correlation coefficient, which tells if there is any relationship between two variables, but it does not tell what kind of relationship exists between both of them. For that, we use regression, which specifies the relationship in the form of an equation. In linear regression, an equation shows how an independent variable affects the dependent variable. For example, how diet affects weight. Following is a formula for calculating a, which is the intercept, and b, which is the coefficient for x. If we have different values of x and y, then we can calculate x into y, square of x and square of y, and take their sum. With n equal to 5 in this example, we can get the values of a and b and the resultant equation. Similarly, there is multiple linear regression, which uses more than one independent variable. For example, how diet and exercise affect weight. Following are the formulas for calculation of a, b, and c of the equation. There is another thing called residuals. It's the difference between the actual value of y which we have obtained from the data and the value of y which we calculate from the equation. Now let's go to R. Now I have already imported MTCAR's dataset which is built in R. Now to find linear regression, we will use the function lm and mention two columns and the data from which columns have been taken, that is MTCARs. Now this will give me the values of intercept and coefficient of HP, which is a and b of the equation. In addition, what I can do is I can assign a variable to this lm function and use the summary function on this variable. This will give me the following results. The first thing we will see is residuals, which I have explained to you already. Generally, residuals for every value of y is calculated, but here we are only given the summary of the residual values, that is the minimum, maximum, the median, and first and second quartile of those values. Next, we see coefficient section, which gives the details of the intercept in first row and the coefficient of HP in second row. Intercept is A and coefficient is B as for the equation. The first column gives the value of the intercept and coefficient. The second column gives the standard error of these values. The third column gives the t-value, which is a statistic calculated for significance, and the fourth column is the p-value of that t-value statistic. We are also given standard error of residuals with degrees of freedom. Then we have R-square value. R-square value is a term used in regression. In layman terms, it tells how much the equation explains the observations within a range of 0 to 1. The closer the R-square value is to 1, the more the equation explains the observed values. Then we get the F statistic and the p-value that tells us the significance of the null hypothesis. The null hypothesis being that the two variables are not related. We can get the same results by using LR, dollar, and then we can write coefficient, residuals, and a number of things in that. For example, LR dollar residuals will give us residuals of all the values of y. Similarly, we can also do multiple linear regression with one dependent column and two independent columns. In the linear regression, we use DISP as the dependent column and HP as the independent column. Now I will add another column to it, that is MPG, by using the plus sign. Now when we will run this and we will get the results, we will get extra row for MPG, which will specify the coefficient for MPG. The equation that we have discussed before, that is y is equal to a plus bx plus cz. So this will be, z will be MPG and c will be the coefficient of MPG. Now using this equation, we can also predict new values of y as well. For example, in case of linear regression, I will take new values of HP in the variable new underscore HP. Now then I will use the predict function, which will mention the LR variable that contains our equation for linear regression, and then the new data, that is the new underscore HP variable that contains the new values of HP. When I will run this, it will give me new values of DISP. So that is it for today. Thanks for watching. If you learned something from this video, please like, share and subscribe the channel.